Okay, so if we look at this assignment, we have two files that we've set up. The app we shouldn't need to really mess with. It's just going to run our unit tests and test all of the features in the other file that we do need to fill out. And so this one is instantiated. We can create many different secure lists. This one is going to be static. It's going to be the thing that, the starting point for our app. That's why we have the main method here. And it's going to create an example secure list with some names that we fill out or that we randomly generate. We get to choose, and then we'll proceed through and test all of each individual unit, each function that SecureList has to offer. So the first thing that SecureList wants us to build are some encapsulated instance variables, some properties that we'll be able to use. And so that looks like something like this. And so we have a SecureList here, and we have them marked as private. By default, they should be private anyway, but we emphasize that to really just underline that we are understanding what encapsulated instant variable mean. So our title, if you want to access it, and that's the first test here in app, that we add a title and then try to print the title. So here's where we access it. Here's where we provide a new title. And because we're accessing it inside of a print statement, then it would both pull it from this new object and then print it. But I lied here because this isn't the first test. The first test is actually using the constructor. So the constructor is the method, and it's a method because you can see these parentheses afterwards activating it. And the constructor is what actually instantiates, what creates a new list in our memory. And so a constructor, we're labeled here. And constructors can be overloaded, meaning that there can be more than one with the same name, and just with different parameters. So if you try to build a secure list without any parameters, any instructions given, then it just fills out a bunch of blank stuff. But if you give one with an array list of names to say, here's my starting names, I'd like you to build the list of names around, then it will loop through that. We'll get to that in a second. To emphasize that most methods don't start with a capital. Constructors have to, though, have the same name as the whole class that they're building. And they don't have a return type. Every other method, if I scroll down here, if you want to get the student by what seat they're sitting in, it will return a string and will return their name. If you want to update the title, this is the mutator, then it will return nothing. It'll return void because it's just taking the title that you want and setting the instance variable to that parameter that you're giving it, and then returning nothing. Constructors don't have a return type because they're returning basically the secure list that you want to build. And so anyway, so they have the same name and no return type, but they can take parameters depending on what kind of ingredients you want to give the builder, the constructor, when you're creating a new item. Two constructors that I've built are very similar. They first call the constructor, this first one that just makes, these are uninitialized and uninstantiated. So that uninitialized means they don't have an initial value. Uninstantiated means they've been declared, but they haven't been created in memory yet. So they've been created in stack memory, but this is a bigger object and needs to run a constructor all of its own, and so which makes this an aggregate object because it has an instantiated object as its one of its properties, and we need to run a constructor to create it in heap memory and prepare all of its cool functions like the add function. So we create a blank array is really easy. But then to make 12 spots already existing in this array list, because it's flexible, it'll just flex as you add new ones. So I'll go through a list, a loop, and I'll crank out 12 blanks, literal strings, and add in all of those to our name list. And so now our name array and our name list are the same. They have 12 blank strings each. So I'll make those blank stuff at the start of each one of these, and then inside. Now this will be different because this one is taking an array list and this one's taking an array. And I'll go through all 12 spots. I'll make sure I'm staying under 12. And just in case you give me an array list or an array that's fewer than 12 items, I'll stop early if I'm about to exceed the size. So I need to stay underneath the last element. Okay, so not underneath the length, which means up to and including the last element. But anyway, so I'll start through a list. I'll say, okay, array at this spot starting from 0 ending at 11. You are now set to the list item. I have to get that item at that at the current position. So I'm just copying one for one over. Position I at the given list, position I at the given array. I'm copying you to the array at the given position. But the array list, this is it works differently than the array. I can't just use the equal sign to assign something. I have to use this set method. So I have to set at position I, you're now equal to the item, get the item from this other list. Or this is position at I, get the item from this array, from the given array, at the same position. So that's how you copy that 1 over. So this is how I construct my list from a provided collection. Mutators are pretty easy. I named them all the same thing as the property itself, just to keep things simple and also to show you that because the parameters are different, it can tell the difference between a mutator and an accessor. So the accessor, if you just say title parentheses, it'll just return this instance's title. If you say title parentheses with a new string, then it'll take this as a local parameter and then update the instance version of title with the given string. So this is how you mutate or update the title. So this is a setter, this is a getter, other terms that are used for accessors and mutators. All right, get name. So sometimes we write them as like this. Get name. Given this index location, I would like to access the name at that spot. But with our gimmicky secure list, we want to see it that when I want to make sure that they're secure, meaning that the names in the two collection match. So if it's not secure, then we say, hey, not secure, return null. But if it is, and I'll go down here and check it, so it is secure, I'll say, okay, get the name at this position, and that should equal the name from the name list at the same position. So they should be the same. And I'm just going to return this comparison. So if they are the same, I'm returning true. If they're not the same, I'm returning false. So that way I'll know that they're the same. So if they are the same, then I just return that. I could also, take care. I could also just return this instead, because I know they're the same. I can pull it from either collection, the array version or the array list version. Get student by seat is the same thing, but not 0 indexed. So for this, I've already built up all this method. So all I need to do is I'll just return the results from get name. And I could have done this .get name, but it's the same thing. And I'll just do s minus 1. Boom. So just like that, I'll then call this one over, and this is non-zero index, so I'll just drop it by 1 and pass it over here and retrieve that name. So that one's super easy. And that's why we call it a wrapper, because it has this at its core. It just allows you to access it from a different point or with different features, or that's what a wrapper means. Okay, we've already done this. The change name is super simple, but we need to change both places. So you have an I and you have a name. we're doing the same sort of thing up here. So I can just sort of collect this, and then paste this down here, change name, boom, Shift Tab, okay, and I'll say, all right, set at, okay, I'm using N instead of I, and then I'm not accessing a special name, I'm just using the given name from the parameter. So whenever you call this, I'm changing that name. So that's easy. Is empty, I just want to see if the spot at that is empty. So I can use the getName method again, and so I'll say is empty. I'll say okay, get the name at n, and I want to see if this equals a blank, right? So and I'll just return that. So return that the spot at this is equal to blank. And if this is true, that it is a blank, then this is returning true. If it's not, there's something there, then this will be returning false. And so it'll accurately tell you if that spot is empty. Boom. Is secure, we've already done. Now this, to check everyone, I just loop through the length of my list. Int x equals 0, x, I'm just picking x randomly. X is less than, I could fix it to 12 because I know that's what I'm building this project around, but instead I can do this dot name list. It could be either one. Name list uses the size method, not the dot length. Size x++. So then that should be 12 items, and so then close this list. Okay, now if any one of them is secure, so if not is secure at position x here, so x will turn into n when it gets passed over here. So if it's not secure, then return false. You know, shut it down. We found one that's not secure. But if I make it through the entire thing, I copied something. Well, yeah, illegal character is so annoying. If it makes it through the entire thing and it didn't find anything, then okay, return true. It's all secure. Alright, get random. Now a random number, we should know how to do this. Random number is, okay, int r. So now I need to make a random number. So that's going to be math dot, I use a parenthesis here, and I'll show you, remind you why in a second. Math dot random. And now that's going to give me a decimal from 0 to 0.99. So I'll multiply that by the length, so, or the size. This dot name list dot size, and that'll give me a full random. But the problem is this is a double. It's a double times an int, which will give me a double. So I need to intify it, and that's why I wrap this around in parentheses. So after you're done with the math, then intify it. Otherwise, because it'll never be 1, if you intify it too early, it'll always be 0. So this will always pick 0. So now I just get the name here. So return self dot, not self, sorry, that's Python. This dot get name at that location. All right. Cool. So that's get random. Shuffle, that's for our next, that's, I'm going to leave that alone. That's for the next unit. Once we get really into 11's activity 3 and 4, I'll come back to that. ToString, build a for each loop, but because I need to print the seat location, it makes more sense to use a traditional for loop. String method, I need to return a string, not just print it. So I'll create a blank string. I'll loop through all of the spots in the array. I could have done the list as well, but either one, they should be the same. And so I'll add each time a student at the spot, and starting 0 up till 11, and I'll get the name, and then I'll add a blank line. And then I return this collection after looping and adding all this stuff up. So if I run my tests, it all prints out, except for the shuffle. We didn't do that, but all of the rest of the stuff is there.